Hello everyone, welcome back. Before going any further on our project development, I would like to share some concepts we can deal with, and this is about session management. So first of all, what is a session management, or what is a session? So basically, you know that when a client sends a request to the server and a server sends a response to this client, right? There's a conversation established between the two, and in this case, there is a link between the two established, and this is basically a session. So a session is a conversational state between the client and server, and it can consist of multiple requests and response between the client and server. Okay, so say one person can have conversation with the server and can have the user session established, and another person can have another session, established with the server as well. It's just different clients but same server. Okay, and some side notes here: HTTP and web server are both stateless. Okay, so we understand that stateless basically means there's no memory or anything that can be remembered in between. There must be something to track, the conversation or this established session. And that's a lot of times a unique identifier or session ID that is needed in order to track this request and response. And there are different ways to provide the session identifier. We can use user authentication. So basically, that's a username and password. When you type in a username and password in the login page, for example, and you send this, credentials to the backend, and then the server knows that you are the right person as long as the credentials and username match up with the record. Okay, in this case, a connection between the two is established, and it will be very tedious every time that a user sends a request. He needs to type in the username and password. So once the user has been identified and check on the credentials, we can use a say HTML hidden field to track the session between between the user and the server. And this HTML hidden field is just one of the fields in the HTML template, and then you make it hidden so that the user won't be able to see it. But every time the server can notify that. But the problem is that is this is usually form based. So when you submit a form, the server can retrieve the field and then get the hidden field, and usually it's just a generated random string. And because it's form based submission, some other things like when you click on a link, which is just a get HTTP request, won't be able to deal with this HTML hidden field. So it's kind of restricted on the form submission, and it's not very flexible to be used. Another thing is that you can use the URL rewriting. Say you append a specific parameter, each time at your URL, so that when the request is sent or respond, server can retrieve that parameter, and the parameter would be, a random generated, string to track this session. Again, and this is not very flexible to be used because the string itself has some vulnerability to the security issue, and also the parameter need to be tracked every time there might be a collision with some other, parameters that user actually requested. So this is not very, convenient to use. So besides that, we have cookies. So cookies basically is a small piece of information that server send back to the browser, and the browser store that in the browser memory or local storage. It has its own, expiration time, and a lot of times it would be a unique string as well. And this is pretty much a traditional way to do uh, session management. But the thing is, user need to enable the browser to accept cookies. Okay, so those are the several ways you can deal with session identifiers. And there are problems with the traditional session management, especially with the next generation movement. We're moving, the infrastructure to the cloud application, and a lot of time there'll be some new requirement generated in the modern application. So, for example, first we want a horizontal scalability for cloud native application. So that is to say, for example, for Amazon, you go to Amazon website, right? It's not just single server doing those things, serving you those content. It's actually at the backend there will be a multiple, thousands of instances at the backend. It depends on the load or the request. Those instances can be scaling up and down. Um, if you just use a basic HTTP session, which is residing JVM for Java in this case, it would be a problem for performance because every time when you have rebalanced HTTP session, you need to take some time, and efforts to regenerate the sessions for different instances. Okay, and another disadvantage is that it requires large heap size as well. So this is not very efficient way for traditional HTTP session management in this cloud-based application age. And another problem is suppose a user has multiple accounts. One person has multiple accounts. This is pretty typical in nowadays. And HTTP session can only track one user or row at a time. So in this case, the user has to log out and log in order to switch between different accounts, which is not very convenient to use. Okay. And again, we have the multi-level security preview. So imagine there is a complicated, enterprise system, and in this system we have different users. Different users have different roles. Different roles will possess different privileges to look at different things. Okay. A lot of times when you design the app, you will make public information which has the lowest security level available for the user. And depending on the user's role, you will have extended content for user to access. If the user say choose to access or click on some links to access more advanced information. But because HTTP session can only deal with one role at a time, in this case, the user has to log out and then log in again for different roles. So again, it's not very convenient to use. And according to a servlet, if you are using, say, WebSocket to develop a application, say there's a chat, application that's based on HTML5, and because you are using WebSockets, and a WebSocket cannot keep the HTTP session alive through the servlet, so if you stay, not active for some time, you might be session out, you might be logged out automatically, which is unexpected in this case. And beyond that, we have other problems like we're trying to access the session data for non-web request. As REST, API is getting very popular recently, and AMQP messaging, the JMS messaging, system is also very popular among large enterprise systems. So those are not accessible to the user information in the HTTP session. So this is another disadvantage. Okay. And then Spring has this Spring Session project that is developed to solve this issue. So basically, Spring Session is easy to write horizontal scalable cloud native applications. It helps to offer the storage of the session into special external session stores, such as Redis. So basically what this means is that instead of storing the session information in JVM alone, it delegates the storage into external storage session. So right now, Spring supports Redis. So this is something similar to a database, but instead of storing things in the hard drive, the Redis basically is a in-memory key value pair that is very high performance. If you're interested, you can search for more information on Redis. So in this project, we're going to use Redis as the external storage tools. And also, Spring Session can help to keep the session alive when users are making requests over WebSocket. Accessing session data from non-web requests, such as JMS message or REST APIs, is also possible. And the Spring Session can support multiple sessions per browser for a richer user experience. And it can help to control how session IDs are exchanged between client servers, which make it easy to write RESTful APIs that can extract session ID from HTTP header rather than relying on cookies. Okay, so basically Spring Session solves the problems we mentioned previously for HTTP session. And also a side note here, so this Spring Session project does not depend on Spring Work. In other words, you can use the Spring Session without using Spring Framework. But since we're using Spring Framework in this project, in this course, so it doesn't really matter. And here we talk about how Spring Session works. So in order to understand how Spring Session works, we need to know that it all sums up to two major questions here. The first one would be how to create a clustered high availability session that can store data reliably and efficiently. Okay. The second question would be how to determine which session instance is associated with which incoming request. So whether this request is through HTTP WebSocket, AMQP messaging, or any other protocol. So the first problem is pretty much well solved by a variety of data stores such as Redis, Gemfire, Apache, Geode, and etc. So Spring will be able to use them to, as the external storage methods to store those data. And we're going to use Redis as we mentioned before in this case. For the second problem, Spring Session just need to define a standard. For the first problem, Spring Session just need to define a standard set of interfaces to communicate with the external storage tools. So basically, we have a couple of instances available. For example, we have the Spring Framework.session, which is an interface that defines the basic capabilities of a session. And we have this expiring session that extends the session interface above to determine whether a session is expired or not. And also we have the session repository, which defines a method to create, save, delete, or retrieve a session. Okay, those are just some examples. And for the second problem, in order to associate a request to a specific session instance, we need to understand those, association is based on specific protocols, okay? And that's because that when the client and the server agree on a way to transmit the session ID during the request and response cycle, is based on a specific protocol. Say HTTP session is based on HTTP protocol, and then we can use the cookies or headers. And also for HTTPS, we can use the SSL session ID. For JMS, we can use the JMS header to do that. Okay, and Spring have different means to deal with this. And then let's talk about the authentication sequence in our case. Since we are doing REST services, REST APIs at the backend, and the front end is Angular 2 app, it's gonna send HTTP request to fetch REST resources from the backend. So what's gonna happen is first from the browser, we're gonna use some methods, say get REST resources through the APIs. And then because we haven't logged in, right? So it will be a 401 response, which is unauthorized. So after the user has logged in, the user can, post their credentials to the backend. So the backend will check the credentials and generate a token, a specific token, a random token associated to this user. And then Angular 2 will have some means to store the tokens internally. And after time, it sends some request to the backend, it has to attach this token as a XOF token at its header. And then the backend will validate the token and send back the response for that. And of course, all this storage for those sessions will be residing in external storage, and we're gonna use Redis in this case. Okay, so that's the overview and big picture of the security mechanism we're gonna use in this project. All right, and if you have any question more interesting in the sprint session, you can take a look at some of the documents. Say sprint session. We have the sprint session project, and it has the reference you can look at. So it has a bunch of information here that you can look at for this documentation, and also it has different samples and guides, like different sample applications and the corresponding guides. Say for example, we have this REST application samples that you can download from GitHub, and also we walk through the samples. How do we actually do that? This is pretty convenient to use. Okay, and that's pretty much for this lesson. We'll continue in the next one. See you. Bye.